Okay, now the slides should be visible to all of you. And I have divided this presentation in 3 segments. So very shortly about Caruna, what is Caruna, and then what is the energy transition, what is behind all of these changes, and what is causing the need, for example, for different kind of analytics and artificial intelligence tools. Then what is the analytic platform in Caruna, what we have done so far, and then in the end, what kind of challenges do we see, what we hope that the analytic and AI capabilities hopefully going to solve in the future. So Caruna, last year, we are electricity distribution company. I'm going to refer it as a DSO later in the presentation. We are the largest in Finland. We have a market share of the electricity distribution around 20%. We have over 700,000 customers, and we have close to 90,000 kilometers of electrical network in Finland. And there you can see the map where our network is located. And of course, in Finland, we have very good electricity networks. Our reliability is close to 100%. So last year it was 99.99. And mainly that is due to the high investment rates. So last year we had 140 million euros investments in our network. And we have a little bit over 300 employees at the moment. Then about this energy transition, what is going to happen? So this is, of course, one way to look at the future and categorize these things. 2020 year is, of course, based on facts, and the next decades presented here is scenario in the future which may happen or may happen in some level. So the consumption in Finland is going to, let's say, static growth can be seen in the future. So the main growth is there in the industry segment, small growth in non-industrial, and the transportation is there mainly due to electrical vehicles. So those are going to come up in the near future. And what is going to happen there on the electricity production side? So of course they need to be produced more electricity because we have a consumption there available. And the renewables are going to be increasing highly in the next decades, and especially the wind power there, and of course solar. And as you can see, the net imports are going to decrease. So Finland is coming more and more electricity independent, so we don't need to import any electricity or that much electricity in the future, for example, for Sweden. And the scenario has been made 2 years ago, I think, and there you can see already one thing that is not happening there. So that is the green segment there. So there is assuming that this Hanhikivi nuclear power plant is going to be online, but that's of course now a little bit question mark that is it going to happen, or is it going to happen in that time frame? And that is also at least partly increasing the need of this renewable energy production methods. For example, that is also increasing the need of the wind and solar energy systems. And then we can look a little bit detailed what is going on there in the electricity consumption and production domain. So there you can see that there is some segments are growing, let's say, static level, and the others are growing, let's say, more close to exponential way. So the industry electricity consumption is going to be growing and growing the next decade, and there is also need to make the industry solutions carbon neutral, which is increasing the need of the electricity. And the wind power, of course, is hopefully matching that need, and it's going to be multiply in the next decade. And I think this is going to be even faster and more windmills are going to come into Finland, and it's presented here in this graph. Then in the consumption side, electrical vehicles, so that is the Finland's aim to have 700,000 electrical vehicles, which half of them would be fully electric in 2030. So there is going to be dramatic change in the consumption side, and of course these heat pumps in homes or even in shopping malls and bigger buildings is going to have a static growth in the future. Then solar power, of course, that is, let's say, still quite small here in Finland, but that is going to dramatically change in the next 10 years. So we would have 2 gigawatts solar power in 2030. And demand side response capacity, what that means, it means that there will be more volatility in both consumption and production sides in the network, and there needs to be a match. When there is an electricity consumption, there needs to be also production, and there would be a mechanism that, for example, the DSO would be able to control partly the consumption of the electricity in homes, for example, heating. And the point there is that the customer wouldn't feel any different. So the house is warm, but we are just balancing the mass of the homes, that they are not heating up directly at the same time. So that would balance the network need and help with matching the consumption and production to each others. Then about data and analytics in Caruna, what we have done shortly. So 2014, we started building the foundations of Caruna, all the ICT systems, all the processes, financial and billing systems, that we have actually the systems that can produce any data, and we can get all the right information out of them. When that was done, we could actually focus on the services and development of those systems and start to actually develop this AI platform we have nowadays, which I'm going to go into a little bit more detail later on. And once we have that ready, we can really focus on the challenges we have in the future towards this energy transition. About Caruna analytic platform, we have built this around Snowflake, so we are utilizing Snowflake here, and we can basically take all our data in multiple different sources into our analytic platform using different kind of APIs from our systems, existing databases, different kind of files, open data available in the internet. So we can put that there in our platform. We are harmonizing the data, syncing the data that they really match to each others. And then we can use that platform to develop our analytic capability. And then we can start building, for example, these different kind of AI systems in the future. And this is quite centralized system here in Caruna. So if there's a place to look some data or you need some kind of analytics, this is the place to look at. And of course, these are, let's say, modern cloud environments. So there is multiple different scaling options available there. For example, in Amazon systems, they have plenty of different analytic resources, which we are able to utilize if we see that reasonable. What else? So we had AI fast track project some time ago. We had an idea to accelerate the using the AI to help in our challenges. We had over 200 ideas. Of course, we didn't have time or resources to go to piloting all of those ideas, but we took 3 best in our cases. So we have a natural language processing tool to automatically analyze different feedback. So we don't have to do any more manual work, and we can easily see the point there. And if we have managed to do well job based on the feedback, then machine vision solutions to analyze the infrastructure needs. For example, if the poles are sitting straight in the forest, if they're not trees on top of our lines, and we, for example, if we have those danger plates in place properly. And then we can go this scenario modeling in the next slide. So 2 different challenges, which are a little bit combined together, we see in the future. And the one is DSO flexibility, and that is actually real data from our network. There is marked as yellow as a prediction, what it would look like, and then the red graph is there, what it actually was. And of course, like if we do things old school, we can construct very strong network that it would handle all the situations, but when there is nowadays a lot of volatility and it's going to be increasing in the future, so there is no point to over strengthen the network if there is only 1% of the time need of the high capacity. So we are looking for other solutions to balance the network and then construct more smarter and cost-efficient network to the society. And those network capacities, there are in different kinds of switching situations. So if we are looking at the black line, we would have more consumption that could fit in the network. And we are looking for solutions to predict those situations and solutions also to manage those situations. And this demand side response would be one way to fix this, to balancing the load. And of course, different kind of energy storage systems would also help in that situation. And then this scenario modeling, there is short time, which we can actually see what is happening in the few hours, maximum few days in our network. Are there going to be situations that we need to do something about it? And then the long time is based on the months, years, that what kind of construction activities we need to active to support that change. For example, we can put there that, okay, half of the people in that area is going to buy electrical car. What kind of changes we are looking for to happening in our network? And then we are utilizing this platform also to the services for the customers. We have Virtanen.fi web service available in Finland in Finnish language. And for example, if you are thinking about solar panels, you can look up there what kind of solar panels is reasonable for you, and you can match it to your own house electricity consumption based on the real history data. So you can log in and see what kind of panels would fit best for your purpose. Then you can create a energy community there as well. If you're looking for, let's say, centralized solar panel systems, you can put it up and running there. And of course, if you are looking for electrical vehicle charging, we can instruct you the correct way how to proceed with this investment.